Greetings to you all lovely viewers. Welcome to this video on technical drawing with Teacher Dixon. Today we're going to take a look at the development of objects in technical drawing. What do we call development? Development in technical drawing is the process of unfolding a three-dimensional object onto a flat two-dimensional plane. All right. Now when you unfold this flat pattern along its layout lines, it recreates the original 3D shape perfectly. It is the geometrical equivalent of flat cardboard or unrolling sheet metal cylinder. The key purpose is why do we use this? It is used in the manufacturing companies, manufacturing workers use template to cut sheet metals, cardboard or fabric. Packaging designers create flat layout by folding the boxes and cartons. And then fabrication engineers design pipes, ducts and boilers before bending them into shapes. So we can now see that this development is essential in almost all spheres of life because production is done almost every day in every sphere. So we have different methods of development, one of which include parallel line development used for objects with constant like prisms and cylinders. Also we have radial line development used for tapered objects with points like the pyramids and cone. The triangular for complex irregular shapes. We have appropriate development used for double curved surfaces like spheres which cannot pattern perfectly without stretching. All right, so these are the four types of development that we have in technical drawing, and we are going to take a look at one of them. All right, at this juncture, we would like to start with the radial line development, which is concerned with the development of prisms, pyramids and cones. So that is what we are going to look at. So under the development of radial lines, I would like us to first of all take a look at development of hexagonal pyramids. So let's hear how we can fix that. So as the name implies, hexagonal pyramid has a pyramid front view while the base is hexagonal in shape. So as you've seen, we've started the drawing already, and we're taking measurements. We're starting by drawing a straight horizontal line as you've seen there, right? So we are taking measurements, say 3 cm or call it 2.5. We are trying to fix the hexagonal shape right away, and hexagonal shape is a six-sided polygon, and that is what we are trying to fix right now. We are ensuring that the measurement taken using the compass is not shaken. That's why we're dropping it there. And right now we're using 60 degrees set square to make the receding line, right? So we're going to the alternate side now to also fix line at 60 degrees equally. So that is what we've obtained there. Having done that, we pick the measurement already taken using the compass, and we cut an arc on the just drawn line, and the same thing on the alternate side. So having done that, we've already gotten 3 sides of the hexagon. All right, to continue, we place our T-square already stocked very well, and at the point of the intersection of the arc and the line that was drawn, we draw another line at 60 degrees facing the alternate direction, and we do the same to the other point. I believe by now we should have been familiar with how to produce a hexagon, right? So I'm telling you that in case you've not gotten the real idea on how to do that. So we've just used the same measurement as taken earlier, and then we've cut other arcs. Having done that, we join the 2 points of intersections, thereby giving us the hexagonal shape as wanted. So that is a regular hexagon drawn already. Now the hexagon so constructed forms the plan of the pyramid, development of pyramid that we are to construct. So the next thing that we are about to do now is to draw the front view. How do we get that, and how does that look like? The front view is much more like an isosceles triangle divided into parts. So to have that fixed, we have drawn a horizontal line after making a gap measurement, maybe a 1.5 cm from the plan. We've drawn a horizontal line. Now we are to make projections from the plan to touch the baseline of the front view. That is what we are doing right away. So each of the points as numbered or given letters, we are projecting lines to touch the front view which we are about to produce. And at this point, we are supposed to take the height, to look for the height of the proposed pyramid we are to draw. So let's say we are looking at maybe 6 cm for the height, because it's going to be an isosceles triangle, a kind of a pyramid. We've already had the base width to be approximately, say, 5. Okay, the fence line so drawn shows the height of the pyramid we are about to produce. So at each of the points at each of the points projected to touch the baseline, we are going to connect it to the height which we have above, and that is what we're doing now. So we've connected that. We connect the next one, ensuring that our pencil is well sharpened. We connect the third one and the last one. Now looking at the front view of a pyramid, we are supposed to only see 3 sides, and that is exactly what we've seen there. So we are to thicken that line, because that's not supposed to be left as construction lines. We are using visible outline, which is a thick continuous line, to produce that shape so that it will be visible to the eye. Having done that, we've produced both the plan and the front view. Now the next is the development proper. How do we fix that? Let's see. Now let us not forget that a hexagonal pyramid has 6 sides. So we are going to produce 6 sides when we are making the curve, and that is what we are trying to do. We are taking the measurements from the height of the front view, and we're drawing an arc using the apex of the front view as a point of focus, and then taking the height to be from there to the baseline. So we are making a curve at that point. Now having done that, now at this point we are to take a measurement of one of the sides of the hexagon, that is the plan. we are taking measurement of one of the sides, and we'll use that to mark off on the axle drawn from the front view. As we have recalled already, hexagon has 6 sides, so we are going to mark off 6 parts to form the hexagonal development, of the pyramid we are considering. So we are still in the process of marking that out. All right, when we finish, we'll give the numbers so as to know which point should be joined to obtain the hexagonal pyramid we're looking for. All right, so at this point we've successfully marked off that. We are to just give the measurement, and then we'll make lines to come from the tip, the central point, call it the center of the curve or arc that we drew. Lines will project from each of the points we've just marked off to the center. So that's what we're achieving right away. Okay, so we've done, I believe, up to 3 now. We're still working on it. Okay. You ensure that your lines are drawn to meet the right points of intersections when you're dealing with technical drawing. There shouldn't be double lines. You shouldn't miss the point that you're to draw and meet. If you take a look at what I am doing here, I have added a small one that will be folded inside. We're supposed to have 6 sides, but I'm making it 7. The 7th is the one you fold inside if you are to carve this out. Remember, development is supposed to be drawn and carved out to form whatever shape, whether you were dealing with sheet metal or whatever fabrication you were doing. So that last point is meant for folding inside so as to achieve what you desired. Now at this point, you agree with me that we've gotten what we're looking for. So the next thing is for us to join the chords between points on the circumference of the arc. So we're joining the points adjacent to each other to form the chord, and those places external, facing the circumference, are going to be cut out. So that's what we're doing right now for us to have the hexagonal pyramid we expected to have. That is so achieved, and we've gotten what we wanted. All right, so we've gotten that in a more simplified way, and it's looking like what we're asked to find out. Hexagonal pyramid has 6 sides. From the plan to the front view and to the development, we've successfully gotten that. So if we are to carve out, there are positions there to be carved